So the RoboDogs have a robot that fires t-shirts into the stands at the football games, and they've asked you to help them determine what the initial velocity of the t-shirt has to be in order to reach a person that's standing on the top of the bleachers. So in essence, they have this robot cannon here that's going to be firing a t-shirt up to someone that's standing all the way at the top of these bleachers up here. So the t-shirt's going to come all the way up like that, and then come down and be caught by the person in the bleachers. What we know, the measurements that they've taken, is we know that there is an X distance that the cannon is going to be placed 50 meters away from the person that's standing on the top of the bleachers. We also know that the bleachers are 11 meters high. So we know this Y value here, that the Y is equal to 11 meters. I'm going to leave it positive because remember the t-shirt's going to land 11 meters higher than it started from. And we know that the cannon is set to fire at 30 degrees. What we want to find out then is what is that initial velocity the cannon has to fire at in order to get to that value. So when I look at this, I think through, this is a 2D problem. So remember, all 2D problems are going to have two different problems, one in the X value and one in the Y value, or X direction and Y direction. So if I look in the X direction, I have X equals VIT plus 1/2 AT squared. The initial the acceleration in the X direction, remember, is 0, so that whole term cancels out. And then I can plug my values in. I have an X position of 50, or an X displacement. In the X direction, the initial velocity is going to be the velocity times the cosine of the angle, so V cosine 30. Remember, Y sine because X is cosine. And one of the things that we don't know is we don't know how long that t-shirt's going to be in the air. Now, that's as far as I can go in the X direction for now, so I'm going to switch over to the Y direction and use the same thing. Y equals VIT plus 1/2 AT squared. I have a Y displacement of 11. Again, my initial velocity in the Y direction is going to be V times the sine of 30 times T plus 1/2 of a negative 9.8 times the T squared. Now, at first you look at that and say, well, I can't solve either of those equations for anything. But at second glance, you notice that there are two unknowns, V and T, and two equations. So if we simultaneously solve these equations, we can get rid of one of the unknowns in order to solve for the other. Since we're looking for this initial velocity, then we'll probably solve this for time, plug it back in over here to get rid of time and to solve for the initial velocity. So if I solve this guy for the time value, I have that the time is going to be 50 divided by V cosine of 30. 50 divided by V cosine of 30. And then I can plug that in for my times over here. So I'll say 50 over V cosine of 30. I'm going to start with this end one just so I don't run out of space. Then I have this one that's going to be 50 over V cosine of 30. And then I can fill in the rest of the equation here. So minus 4.9 is that term. And then over here I'm going to have V sine of 30 and equals 11. Now notice that I have one equation with one unknown, my V values. So the rest of it is just simplifying. So I'm going to take this and say, hey, I have a velocity here and a velocity here that can be canceled out. The sine divided by the cosine is going to be the tangent. So 50 tangent of 30 equals 11 minus all of that term. Well, if I subtract this over to the other side right away, I'm going to end up with a negative 17.87 equals the rest of this term. Now, if I take a negative 4.9 times 50 squared divided by the cosine of 30 squared, I end up with a 16,330 times 1 over V squared. And that's what's going to go here, 16,330, 1 over V squared. Divide by that, flip it to get this into the numerator, and you get V squared is going to be equal to 0.00194447, and then square root that. And you end up with a final velocity, or the initial velocity in this case, of 22.7 meters per second. So the RoboDogs are going to have to get their robot to fire the t-shirt at an initial velocity of 22.7 meters per second in order for them to hit this person that's standing at the top of the bleachers. Now, that is only under these conditions, though. 50 meters away, 11 meters high, and firing at an angle of 30 degrees. And if we want to get even more specific, we would look at that and say, well, there's going to be a little bit of air friction. So we probably want to say that this is the minimum velocity that we shoot it at. We're going to want to fire it at slightly more than that so that it overcomes the air friction in the problem.